So this video is for class 10th. The chapter is triangles and I've solved here exercise 6.4 of NCERT textbook. Okay. Now the next first question. So class 10 it is chapter triangles exercise 6.4. Question number 1. Triangle ABC is similar to triangle DEF and their areas be respectively 64 centimeter square and 121 centimeter square. If EF is equal to 15.4 centimeter, find BC. That means area of triangle ABC is 64, area of triangle DEF is 121. EF is given, I have to find BC. Now let's draw the solution. First let's draw the figure. So triangle ABC, suppose name it ABC. We have got another triangle DEF. DEF. These two triangles are, this triangle is 64 centimeter square and this triangle area is 121 centimeter square. These two triangles, in this base length is given 15.4. I have to find this base length. Okay. So these two triangles are similar, it is given. If triangles are similar, we know that the ratio of the areas of two similar triangles is equal to the ratio of the squares of the corresponding sides. So because the triangles are similar, this ratio of the square areas must be equal to the squares of the ratio of the corresponding sides. So it is, therefore, you will have area of triangle ABC upon area of triangle DEF is equal to BC square because we are considering the base length. So BC square upon EF square. Let's put the values. 64 upon 121 is equal to BC square upon 15.4 square. So don't take the square of 15.4. So instead you take the square root. You're taking square root of both sides. Or if you take square root of 64 upon 121 is equal to square root of BC square upon 15.4 square. Square root of 64 is 8 and square root of 121 is 11. So it will be 11 upon 8. 8 upon 11 is equal to this square and this root both cancels. So it will be only BC. And here also this square and this root cancels. It will only 15.4. Take this 15.4 and multiply with 8. You will be getting 8 into 15.4 upon 11 is equal to BC. When you multiply 8 into 15.4, you get 123.2 divided by 11. When you divide this, you are getting BC as 11.2 centimeters. So the length of BC is 11.2. So when such a situation is there, always go for square root. Don't take the square. It could become more complicated. Okay. Next question number 2. Let's see what's the question. Diagonals of a trapezium ABCD with AB parallel to CD intersect each other at a point O. If AB is equal to 2CD, find the ratio of the areas of triangle AOB and triangle COD. Now let's go for the solution. So it's a trapezium ABCD. So let's first draw a trapezium. So we have a trapezium. Let's name it AB parallel to CD. So A, B, C, D. Okay. So this and this are both parallel. Now he talks about diagonals. So let us draw the diagonal. Diagonal DB, diagonal AC. Both are intersecting at O. So that means this point is O. So name it O. Okay. Now we are given AB is twice CD. That means this length is double of this. That means this is 2CD. Okay. Now you have to find ratio of areas of triangle AOB, AOB and COD. So this triangle and this triangle. So let us see. So in triangle AOB and COD, AB is parallel to CD. AB is parallel to CD. Because these two are parallel, this angle must be equal to this angle. Angle OAB is equal to OCD. These two angles are equal. Why? Because they are alternate angles. Similarly, this angle and this angle should be equal, that is OBA. Angle OBA is also equal to ODC. ODC. Why? Again, they are alternate angles. So these two angles are equal to these two angles of this triangle. That means these two triangles are similar. Therefore, you can say triangle AOB and similar to triangle COD. These two triangles are similar by which rule? By AA similarity criteria. So because these two triangles are similar, the ratio of the sides must be equal. So since the triangles are similar, the ratio of their areas must be equal to the ratio of the squares of the corresponding sides. The area of triangle AOB upon area of triangle COD is equal to, since we know about these two, so let us take these sides. AB square upon CD square. So AB square is equal to 2CD. So let's put that value in place of AB. So, but AB is equal to 2CD. So when you take that 2CD whole square upon CD square, so this will become 2 square is 4 and CD square upon CD square. So CD square will cancel. These two will cancel. So you will be left with 4 upon 1, that is 4 is to 1. So ratio of their areas EOB and COD is 4 is to 1. Question 3. Third question. In the figure, triangle ABC and DBC are two triangles on the same base BC. If AD intersect BC at O, show that area of triangle ABC upon area of triangle DBC is AO upon ODO. So triangles, two triangles. Okay. Now see here, ABC and DBC are two triangles on the same base BC. BC is a base. So A, B, C and D, B, C are two triangles on the same base BC. This is a base which is common to both the triangles, this triangle and this triangle. Okay. Now we have to prove that area of triangle ABC, that means area of this triangle upon area of this triangle, you have to find the ratio. To take this ratio, we need to prove these two triangles similar. So what we do? See the solution, what we do? We do a bit of construction. In triangle ABC, when I talk about this triangle, upper triangle, I'm going to draw AL perpendicular to BC. That means from here, I'll be drawing on perpendicular to this BC line. See this, A, and now let us name it L. So this is perpendicular, okay? And I'm going to draw in this triangle, in triangle DBC, I'm drawing DM perpendicular to BC. DM perpendicular to BC. Okay. Now, in triangle ALO, that means this small triangle, ALO and DMO, that is these two triangles, angle ALO and is equal to DMO is equal to 90 degrees. And because we have constructed them 90 by construction. Clear? So this is 90, this is 90 by construction. Then this angle here, see this angle and this angle, this angle. These two are equal. Angle AOL is equal to angle DOM. These two angles are equal. Why are they equal? They are vertically opposite angles. So that means this angle is equal to this and this is equal to this. That means by AA criteria, these two should be similar. Therefore, triangle ALO, that means ALO, this triangle, and DMO, these two triangles are similar by AA similarity criteria. Because these two triangles are similar, the ratio of their sides must be equal. So that means, since the triangles are similar, the ratio of their sides must be equal. Therefore, AL AL upon DM, that means the perpendicular ratios of the perpendicular, is equal to AO upon DO. This is, let's number this. Say this is first equation. Now, triangle ABC and DBC, that means now we are taking the whole triangle A, this full triangle and this full triangle. Okay. So in these two triangles, area of this triangle is half base into height, BC into AL. Half BC into AL. And area of this triangle is half BC into DM. So half base into height is the thing. So here what happens? Half BC gets cancelled, half gets cancelled, you'll be left with only AL upon DM. And what is AL upon DM? See here, AL upon DM is also equal to AO upon DO. That is, it's also AO upon DO. That means area of triangle ABC upon area of triangle DBC is equal to AO upon DO. Yeah. Next. Because these two are equal, therefore we say these two triangles are, ratio is AO upon DO. Fourth question. If the areas of two similar triangles are equal, prove that they are congruent. The areas of that similar triangles are equal. Okay. This is one triangle ABC and this is another triangle DEF. These two triangles, it is given that these two triangles, their areas are equal. These two triangles are similar. Okay, the triangles are similar and their areas are also equal. So triangles ABC is similar to triangle DEF and this is given, and area of triangle ABC is equal to area of triangle DEF. This is also given because two similar triangles and area equal. Both these are given. Now, let's take, but we know that area of triangle ABC upon area of triangle DEF is equal to AB square upon DE square equal BC square upon EF square is equal to AC square upon DF square. Ratio of the areas of two similar triangles is equal to ratio of the squares of the corresponding sides. So AB square upon DE square, this base BC square upon this base EF square is equal to AC square by DF square. Okay. But these two areas are equal, it's already given. So these two gets cancelled, one and you get 1. That means this whole ratio is equal to 1. That means AB square upon DE is 1. BC square upon EF square is also 1. AC square upon DF square is also 1. So here you get AB square upon DE square is 1. Let's take it this side. It becomes AB square is equal to DE square. If the squares are equal, then square roots also must be equal. That means AB is equal to DE. Now, let's take the second ratio and say it is equal to. Now here, BC square is equal to EF square. Take square root of both sides. It is BC is equal to EF. Third ratio, AC square upon DF square is equal to 1. That is, AC square is equal to DF square and AC is equal to DF. Now, if you see this side of this triangle is equal to this side. Base length is equal to this base length. And the third side is equal to third side. All three sides of this triangle are correspondingly equal to the three sides of the other triangle. So, therefore, in triangle ABC and DEF, AB is equal to DE, BC is equal to EF, and AC is equal to DF. Since the three sides of one triangle are equal to the corresponding sides of the other triangle, the two triangles must be congruent by SSS congruency. Therefore, triangle ABC is congruent to triangle DEF. Question number 5. DEF are respectively the midpoints of AB, BC, and CA of triangle ABC. Find the ratio of the areas of triangle DEF and triangle ABC. See, let us see, you need to draw the figures to get an idea. So let us see, this is a triangle, okay? It is ABC. Triangle is triangle ABC. Now, D is the midpoint of AB. AB is here. So, D must be the midpoint here. So this is D. E is the midpoint of BC. So this B will be here. And F is the midpoint of CA. CA. This is F. Let's join them now. When you join, you get DE join, EF join, join. So you get a small triangle DEF here. Okay, DEF. So you have to find the ratio of this small triangle by this full triangle ABC. Now see, there is something called midpoint theorem which we learned in 9th standard. So as per that theorem, it states that line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half of it. It's a line segment which is joining the midpoint. For D, E, and F are the midpoints. So a line segment which is joining the midpoints of two sides of a triangle is parallel to this third side, and its length will be half of this length. Line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half of it. So this side is parallel to this and it is half of this. This is parallel to this side and it is half of it. Okay. So that is, we are using this concept. That means D and E are the midpoints of the side AB and BC. D is the midpoint of AB and E is the midpoint of BC respectively. So when they are, that means DE, that means what you can say, DE is parallel to AC. So DE is parallel to AC. If DE is parallel to AC, it is also parallel to AF because AF is a part of AC. So that means DE is parallel to AC is parallel to AF and DE is equal to half AC and DE is equal to half of AC. Half of ACF is a midpoint. That means it should be equal to half. Half of AC is nothing but AF. Therefore, I have written DE is equal to half AC, which is equal to AF. That means this side and this side are equal and they are also parallel. Since opposite sides are parallel and equal, ADEF is a parallelogram. ADEF. ADEF is a parallelogram. So E and F are the midpoints of the sides of BC and AC. E and F are the midpoints of BC and AC. So this should be parallel to AC and it should be equal to half of AC. So let's write it. EF is parallel to AB. EF is parallel to AB. It's also parallel to DB. Okay? And EF is half of AB. That means is equal to DB. Because D is a midpoint. So half of AB is nothing but DB. So since opposite sides are parallel and equal, DBEF is a parallelogram. So I am getting this is also a parallel. I got this as a parallelogram. And here I got this as a parallelogram. In triangle DEF and triangle ABC. D, D, E, F. I'm taking the small triangle and the complete triangle ABC. In this total, that means this triangle and this complete triangle, angle A, this angle is equal to this angle. DEF, why are they? And angle B is equal to angle this. In this parallelogram, okay, this is equal to this. Therefore, why opposite angles of a parallelogram are equal? Opposite angles, that is a parallelogram. So this angle is equal to this angle. And here this is a parallelogram, so this angle is equal to this angle. Opposite angles of a parallelogram are equal. Therefore, triangle DEF is similar to triangle ABC because these two triangles are similar by a similarity criteria. So we can say this is your figure, but the ratio of the areas of two similar triangles is equal to the ratio of the squares of the corresponding sides. Therefore, area of triangle DEF upon area of triangle ABC is equal to EF square upon AB square. EF. EF square upon AB square. That is because EF is half AB. EF is half of AB. So we write half AB square upon AB square. So what happens? So half 1 square is 1, 2 square is 4, and AB square. AB square will cancel. So what is left? 1 upon 4. That is 1:4. The ratio of this triangle to the ratio of the complete big triangle is 1:4. This is a sum. Okay. Next. Question 6. Prove that the ratio of the areas of two similar triangles is equal to the squares of the ratio of the corresponding medians. Solution. What is given? Triangle ABC is similar to triangle DEF, and AP and DQ are their medians. So to prove, what you have to prove? You have to prove triangle ABC upon area of triangle DEF is equal to AP square upon DQ, the square of the medians. Now, so this is a triangle ABC, A, B, C, and you got another triangle D, E, F. Now we draw the median. Median was what? Line segment joining the midpoint of a side to the opposite vertex. This is the median. So let us draw it. This is your median because this is the midpoint. So let's name it P. Now let's draw the midpoint of this and join it to this. The median of this triangle. The median. So let us name this as Q. Okay. So AP and DQ are the medians. And these two triangles now, proof is, let's take this triangle. Since the ratio of the areas of two similar triangles is equal to the ratio of the squares of the corresponding sides, so we can write area of triangle ABC by area of triangle DEF is equal to AB square upon DE square. Okay, so let's number this as first. Yeah. Now we consider this side triangle and this side triangle. Okay. This is a triangle. Now we are going to talk about this side triangle and this triangle. Okay. In triangle ABC and similar to triangle DEF, since these two triangles are similar, AB upon DE is equal to BC upon EF. AB upon DE is equal to BC upon EF. Well, if the triangles are similar, the ratio of the corresponding sides are equal. So that's how from that we say that these two, this side by this is equal to this base by this. This is ratio equal. Now AB upon DE, BC is double of BP because P is a midpoint. So you can BC you can write it as 2 BP and EQ can be written as 2 EF. EQ is can be written EF can be written as 2 EQ. So here 2 cancels. It will be just equal to BP upon EQ. Let's number this as second. Now, thus in triangle APB and DQE, we have AB upon DE is equal to BP upon EQ. AB upon DE is equal to BP upon EQ. And angle B is equal to angle E because triangles, similar triangles, their angles, corresponding angles are equal. So this base angle and this base angles must be equal. So two sides are an included angle. That means therefore by SAS criteria of similarity, we have triangle APB is similar to triangle DQE. So because these two triangles are similar, we can say BP upon EQ is equal to AP upon PQ. Let's say this is the third equation. Now, AB upon, now you see, AP upon BP upon EQ is equal to AP upon DQ. BP upon EQ is equal to AB upon DE. That means BP is also equal to AB. So let's replace this with AB upon DE. So AB upon DE is equal to AP upon DQ. So from where we get it? From second and third. This one and this one. From these two we can say this is equal. Now let's take the squares. AB square upon DE square must be equal to AP square upon DQ square. If the sides are proportional, then the squares also must be proportional. This is your fourth equation. So now area of triangle ABC upon area of triangle AP is equal to AP square upon DQ square. So area of triangle is equal to AB square upon DE square. But AB square upon DE square is equal to AP square upon DQ square. So from 1 and 4, we can say that this area of triangle ABC, area of triangle ABC upon area of triangle DEQ is equal to AP square upon DQ square. That means square of the corresponding medians. Seventh question. Prove that the area of an equilateral triangle described on one side of a square is equal to half the area of an equilateral triangle described on one of its diagonals. This is a square. Okay, because it's a area of equilateral triangle described on the side of a square. So this is a square. Let's name it A, B, C, D on any one of the sides. So on this side, I'm going to draw a equilateral triangle. That means if BC length will be here, I'll draw the same, taking the same length, I'll draw a triangle here. So this is a triangle. So this BC is equal to this side because it's an equilateral triangle. Now let me name this point E. So BEC is a equilateral triangle. Now I am going to draw described on the diagonal. So on the diagonal, this is the diagonal. Here I am going to draw one triangle. This is a triangle. Let me name this point F. So that means I have to prove that area of this triangle and area of this triangle. So area of this triangle is half the area of this triangle. That's how we are going to prove. Now what is given here? We are given a square ABCD equilateral triangles BCE, BCE and ACF are described on the side BC and diagonal AC respectively. This much is given. What you have to prove? You have to prove that area of triangle BEC, BEC, this triangle is equal to area of triangle, half the area of triangle ACF is equal to ACF. Now, let's go for the proof. Since triangle BCE and ACF are equilateral, this triangle is an equilateral triangle, this is also equilateral triangle. Each angle is equal to 60 degrees. That means each angle is equal to 60 degrees means these two triangles must be similar. That means BCE and ACF both are similar. Because these two are similar, the ratio of this areas must be equal to square of the corresponding sides. That means area of triangle BCE upon area of triangle ACF, area of triangle ACF is equal to this base BC square upon AC square. Okay. Now, BC square upon AC. AC is root 2 BC whole square. So if you take the square, it will become BC square upon 2 BC square. Root 2 and 2 cancels and it is only this. Now, it will be this BC cancels. We have just 1 by 2. So take this one this side. It will become, this will imply that area of triangle BCE is equal to area, half the area of triangle ACF. Yeah. Next. Eighth one. ABC, BDE are two equilateral triangles such that D is the midpoint of BC and ratio of the areas of the triangle ABC and DEF, BDE is. Four options are given. Now let's see how is triangle ABC and BDE. So this is ABC. This is a triangle ABC. BDE is equal triangle. D is a midpoint. He says D is a midpoint of BC. So if D is the midpoint of BC, let's take the midpoint here, D. This is the midpoint of BC. We draw an equilateral triangle BDE. Let's draw one triangle here. It's like this. And name it here. So that means this triangle is an equilateral triangle. And this is also an equilateral triangle. Both the triangles are equilateral triangles. So that means since triangle ABC and BD are equilateral, each angle is 60 degrees. Therefore, triangle ABC and triangle BDE both are similar because they are similar by AA criteria. Therefore, the ratio of the corresponding sides must be equal. So BC is double of BD. So BC can be written as 2BD whole square upon BD square. So the square, when you take it, it becomes 4BD square upon BD square. BD cancels. So 4 upon 1. So ratio of the ABC upon D is 4:1. That means your answer is option C. Now, next. Ninth question. Since the two similar triangles are in the ratio 4:9, areas of these triangles are in the ratio we have to find. Two similar triangles are in the ratio. Sides of the two similar triangles are in the ratio 4:9. So see here. Suppose the two similar triangles are ABC and DEF. Then area of triangle ABC upon area of triangle DEF is equal to square of the corresponding side. This is the theorem. Now, the sides are given as 4 and 9. So that means BC is 4 and EF is 9. Let's put it 4 square upon 9 square. It is 16 upon 81. That is 16 is to 81. Area of triangle ABC upon area of triangle DEF is equal to 16 is to 81. Whereas 16 is to 81, it is D. So the answer is option D. Yeah. So if you keep watching the thing and always please subscribe for the channel and also click on the like button and share it with your friends, which they can be also useful. Please click on the like button before you leave the video. Thank you.